The output that you see on the screen here looks very similar to the output that was produced from StatCrunch. So the multiple comparisons from Minitab serve the exact same purpose that the multiple comparisons served in StatCrunch. In an ANOVA, if the null hypothesis is rejected, we need to do further analysis to determine what differences exist between all of our means. So what we have in this output is we have information for all possible pairs of means. So in our first block of output, that's going to compare the time of day after lunch to the 3 other time periods. So if we look at our first confidence interval that's presented, that compares the mean count before lunch to the mean count after lunch. And what we see is both our lower and upper bounds of the confidence interval are negative, which allows us to conclude that the mean bacterial count after lunch is greater than before lunch. If we look at our second interval that's given, this interval compares the mean count at the end of the day to the count after lunch. For this interval, we have a negative lower limit, but a positive upper limit. So since the signs of those two endpoints are different, we're unable to say that there's a difference. Now, if we compare the start of day to after lunch, again for this we see negative lower limit and a negative upper limit, allowing us to conclude that the mean bacterial count after lunch is greater than the mean at the start of the day. So with those 3 comparisons finished, we need to continue and compare the before lunch time of day to the other 2 remaining time periods. So that's what the second block of your output does. So if we look at our first interval, end of day is compared to before lunch. For this interval, we see 2 positive limits. We have positive 1.3 as our lower limit, 1.23, excuse me, and positive 9.926 as our upper limit. So we can conclude that those means are significantly different, and what we can say is that the mean bacterial count at the end of the day is greater than the mean before lunch. And if we go to our next interval, we see that if we compare before lunch to the start of the day, we have a negative lower limit and negative upper limit, allowing us to conclude that the mean bacterial count before lunch is greater than the mean at the start of the day. So with those 5 comparisons out of the way, there's one more comparison that needs to be made, and that's comparing the count at the end of the day to the count at the start of the day. So if we look at the final confidence interval that's given, we see again we have a negative lower and upper limit, allowing us to conclude that the mean bacterial count at the end of the day is greater than at the start of the day. So if we kind of go back through this, there was only one instance where there was no significant difference, and that was after lunch compared to the end of the day. All of our other comparisons resulted in some significant difference. So if we think about what we're able to conclude, here's what we're going to be able to say. So there was no significant difference between the mean bacterial counts measured after lunch and the mean count measured at the end of the day. But if we look at all of our other intervals, one can come to the conclusion that the mean count at the start of the day is the smallest, and the mean count before lunch is the second smallest. But I can't make any statement about the end of the day compared to after lunch. In terms of the analysis that we've done, there is no significant difference between those 2 time periods. Now, you'll notice on the Chapter 9 notes that are up, for every practice problem, I provided you with this output. But be careful, you only need to use the multiple comparison output if the null hypothesis has been rejected within the analysis of variance. Now, also on StatCrunch, I'll post a report that goes through this problem as well, that goes through the assumption checking, which I did not include in this video. That will be included in the report process. The assumptions are similar to what you've seen in the one-way ANOVA. So we do need to check to see that our response is normally distributed, and we also have the same standard deviation assumption that we've had in the past. The practice problems are posted on Blackboard. They're similar to what you've seen here. If you have any questions about this material, please let me know.